When you move beyond simple paths and shapes, two useful features of SwiftUI come together to create beautiful results with remarkably little work. The first is CGAffineTransform, which describes how paths should be rotated, scaled, and even sheared, like twisted around. And the second is an even-odd fill, which lets us control how overlapping shapes should be rendered on the screen. To demonstrate this, we're going to create a flower shape out of several rotated ellipse petals, with each ellipse positioned around the center of our circle. The mathematics behind this isn't too complex, with one exception. The CGAffineTransform measures rotations in radians rather than degrees. Now, if it's been a while since you did radians at school, what you got to know is there are 3.141 radians in 180 degrees. And therefore, there's twice that in a full circle. That's not a coincidence. It is pi radians is 180 degrees. That's what it is. So, we're going to write some code to make our flower, drawing the petals one at a time. There are a handful of catches I want you to know ahead of time. Not too much detail, just a handful of catches. The first one, the biggest one by far, is rotating and then moving is not the same as moving then rotating. If you imagine turning someone 90 degrees to the right and saying walk forward 10 paces, then telling someone else walk forward 10 paces, then turn 90 degrees to the right, that's the difference. You end up in very different positions. Second, to really help you understand what's going on here, we're going to use some little properties to make our code a bit clearer. We can pass in externally to control the way our petals are drawn. And third, ranges like 1 through 5 are great if you want to count through numbers one at a time. But if you want to count in multiples, or in our case, we're going to count in pi divided by 8, so we have 16 petals around the clock, we're going to use a different function called stride from to by. From a number to another number by a third number. Let's write some code. I'm sure you're sick of me talking already. There's a struct flower, which is a shape. We'll start up by defining how much to move this petal away from the center. So I'll say our petal offset is minus 20.0. So move 20 points away from the center. Second, we'll define how wide to make each petal. So we'll say var petal width is 100.0. And now comes our path in rect. First things first, we want one path, var path even, that will hold all the petals. And now we're going to count from 0, which is 90 degrees to the right in regular world stuff, but 0 here, all the way around to 360 degrees in radians. And we'll do so 1/8 of pi each time. So remember, there are pi radians at 180 degrees, so there's 2 pi in 360 degrees. So 1/8 of pi means we'll have 16 petals going around the way. So we'll say, for number in, I'll use stride from 0 to double dot pi times 2 by double dot pi divided by 8. So count in 1/8 of pi each time, counting up to 360 degrees, so 2 pi. We're then going to rotate our petal by the current value of our loop. So rotate by 1/8 of pi, 2/8 of pi, 3/8, 4/8, 5/8, 6, and all the way around, yeah? Let rotation be a CGAffineTransform with a rotation angle, and it's a value here in radians, we'll say our number. So we rotate first. We then move the petal to be at the center of our view. So we've turned it first. We're now going to move in the direction we rotated. So we rotate, then move. We'll say let position is that rotation concatenating another transform. So adding this transform to the first transform. Rotate, then move. This will be another CGAffineTransform with translation x and y. how far do we want to move? So we'll say we want to move rect.width divided by 2, and then rect.height divided by 2. So half our drawing space. Now we're going to make a path for this petal using its properties, plus a fixed y and a fixed height. So we'll say, let our original petal be a path. And we're going to use the ellipse in initializer. Give me an ellipse in a certain rectangle. What rectangle? Well, CG rect. X will be our petal offset. Y is going to be 0. No Y. Our width will be our petal width. And our height will be half the available space. So rect.width divided by 2. This is our original petal untransformed. We're now going to apply the rotation and position to the petal. We'll say, let rotated petal be the original petal, applying our position. Remember, position is rotation plus this translation, the movement X and Y. So now I've got a rotated petal. And we can now add that to our path. We'll say path.add, path, rotated petal. At the end, we're done. We can send back the main path. I know that's quite a lot of code. And you're thinking, where's the point in this? It's going to become real clear soon. You'll be glad you followed so far, trust me. I'm going to modify your content view. So we actually use this path. We're going to say inside here, we have state to store the petal offset, and it'll be minus 20.0. And state to store the petal width, which is 100.0. Then inside our body, we're going to create a little layout for doing all these things. Oops, I need the var keyword here and here, my mistake. A little layout. We'll say, first up is our flower shape. This will have our petal offset and our petal width. We'll then stroke it in red with a line width of 1. Below that, let's press preview. You can see what it looks like already. It's the beginnings of our flower. There we go. Very nice. We're going to add some options. So we'll say the first one is offset. This will be a slider with a value of $petal offset in the range of minus 40 up to 40. And add a little bit of padding here of horizontal and bottom. That's our petal offset. We'll then have options for petal width. So we'll say text width. Slider value will now be petal width in the range 0 through 100. And I'll do a bit of padding here to horizontal only. And now I'd like you to go ahead and run the code. So you can see exactly what our code has been doing all this time. All that math we did earlier, transforming rotation and position and so forth. Hopefully you can now start to see what we've actually built by just dragging these sliders around, dragging offset and width around. And you can see really it's just a bunch of rotated ellipses. It's all you're seeing there again and again and again, rotated around the same center circle. So I'll grab offset and pull it apart like this, or in, and our width in and out. It looks really nice, I think, given it hasn't taken a lot of work. Beautiful. That in itself is, I think, interesting. But with one small change, we can go from interesting to, quite frankly, sublime. If you look at the way our ellipses are drawn here in my preview, you can see they overlap. The shapes overlap as they're drawn. This ellipse here overlaps this one and this one and this one. Multiple of them overlap again and again and again. So one ellipse is often drawn over another, and sometimes several others. Not always, because you can adjust offset and width to be different, but a lot of the time they do. Now, if we want to, rather than stroke our flower, we could say, I want to fill the whole thing with red. You'll get sort of a big lumpy blob. You'll get, hopefully, it'll preview a second, you get that. Which, I mean, it's quite nice, but it's not magic. As an alternative, we can fill the shape using the even-odd rule, which decides which part of a flower path should be coloured depending on the overlap it contains. And it works like this. If a path has 0 overlaps, it's filled. If a path overlaps one other path, the overlapping part won't be filled. The rest of it will be filled. If a third path overlaps those first two, then it will be filled. Fourth one won't be filled. Even odd, even odd, even odd, and so on. So only the parts that actually overlap are affected by this rule, and it creates remarkably beautiful effects with just trivial code. So we can say fill here with red, but then pass in a fill style. We can say the fill style has EO fill, even odd fill, of true. And now we end up with something quite beautiful. You can see it right there. It just looks really, really nice. And you can sit and futz with this for quite some time, dragging upwards, in and out, and just create the most gorgeous, interesting effects by just noodling around and trying things out. It really is quite beautiful for hardly any work at all.